So in section 8.2, this is all about the graphs of polar equations. There's some simpler equations and some more complicated ones. Today we're going to look at some of the simpler ones because that's going to help you when you have to identify rectangular equations in section 8.1. Okay, so when you're finding the equations, like the first, when we did that equation in the circle, some of you guys were confused because it's been a while since we dealt with circles. So we're going to review some of that along with another type of equation that you will see in 8.1. Okay, so in your textbook, it says read the intro and then read through example 1. So we're going to do that together. Okay, so your intro to polar equations just tells you that your R value, to find the R, you're plugging in theta, and that consists of all the points that have at least one polar representation of this point R theta, and those coordinates are going to satisfy the equations. Okay, and we've been graphing on the rectangular coordinate, but we can easily and naturally graph things easier on the polar coordinate, especially when you have different curves. So we're going to look at that on the second page. They just show you some examples of different points on your polar grid versus your points on your rectangular grid. Okay, and we are going to graph this. We're going to end up graphing this on our calculator, okay? So if you want to grab that, you can, your graphing calculator. Okay, so example 1 says sketch a graph of the equation R equals 3, and then express it in rectangular coordinates. So in the intro, we said that it's going to consist of all of the points that satisfy this equation. So if the R value is 3, you would go out 1, 2, 3. Well, that happens at every place along this polar coordinate, and that's why it's going to form a circle. Every point with an R value of 3 is going to make that circular shape. Okay, so if you look at this, if the R value is 3, what does that correlate to with the circle? Yeah, it correlates to its radius. Okay, so in your note packet, it says if you're given the polar equation, R equals N, where N is any integer, what shape can you assume this will make? So based on example 1, we can all assume that it's going to make what? A circle. It also asks you about a characteristic that shape will have. Okay, so in this case, R was 3, the radius is 3. If R is equal to N, we can say that the radius is going to be what? With N. Okay, so it's going to be a circle with a radius of N. Okay, and then we're going to graph this on our graphing calculator. So to do this, you have to switch to polar mode. Okay, and then once you switch that to polar mode, I want you to see what happens when you press the Y equals button in order to graph. Okay, so you have to go to the polar first, and then you're going to press that to see what happens when you graph. Okay, so when you press Y equals, what do you see? Yeah, it's R now. Instead of Y, it's going to be R. Okay, so I want you to plug in R is equal to 3. Okay, now when you grab it, does it look like a circle? No, it looks like what? Looks like an oval. Okay, so when you went to your mode, okay, you're going to select polar. Okay, you go to Y equals, you have your R, your 3. If I go to my Z standard, I have this. But I know it's a circle because the radius is 3. You can count and see it's 3, 3, 3, and 3. So your calculator will show you this. If you just press zoom and go to square, it will show you the circle. Okay, if you make it in the square, it will show you that shape. Okay, and sometimes depending on your calculator, it's hard for it to get those round edges exactly. So depending on what model you have, you may have a sharper circle. Okay, so this is going to be a circle with a radius of 3, and where would the center be in this case? 0, 0. Okay, and I know I showed you that example in your book, but if you look here at the equation, if you didn't notice it before, it is x squared plus y squared equals 9. Okay, 0, 0 is going to be your center. All right. So the next one we're going to look at, this says that we're going to sketch a graph of the polar equation, and we're going to express it in rectangular coordinates. Okay, this is also something you're going to be doing in 8.1. So this time, instead of R equals, we have theta equals. This means that the graph consists of all points whose theta is pi over 3. And we can graph that just based on our knowledge from yesterday, because we talked about how if your theta value is pi over 3, okay, if you have a positive R value, it would consist of all of these points. Okay, so at pi over 3, all of these points are going to satisfy that equation if R is positive. If R is a negative, okay, where would those points be? And what? And where would they be? Yeah, 4 pi over 3. Okay, so in the quadrant directly opposite. So remember yesterday we talked about how they're pi units apart, or they're in the opposite quadrant? Does that ring a bell? Right, if R is negative, it would be in the opposite quadrant, so it's all of those points as well. Okay, so if you are describing this graph, this is just going to be a straight line. On pi over 3 that passes through the origin or the pole. Okay, whichever way you want to say that is fine. Okay, so a straight line on pi over 3 that passes through the origin. Okay. Now, the reason why we're looking at this today is because you are going to have to do rectangular coordinates in 8.1. So we've talked about one type, how you have the circle, okay, the circle equation, but theta is going to be a little bit different. So I had you graph that from knowledge. I didn't have you graph it in your graphing calculator, because when you're graphing a line, if you think y equals, right? If you're graphing a line, you always have y equals, you don't have x equals. This is similar for polar. You're always going to have r equals, you don't have theta. So r is similar to y, theta is similar to x. But if you have a straight line in rectangular coordinates, a straight line is marked with what form? What's the common form of a straight line? what's a linear form? Yeah, y equals mx plus b, right? Okay, so when you are finding rectangular coordinates, you're going to put it in the form y equals mx plus b. Now to get there, we're going to use the tangent of theta equals y over x. And you're going to plug in theta because that's what's given to you. Okay, so we're using those same formulas that we talked about in 8.1. So your tangent is going to be of pi over 3. That's your theta value. It's still equal to y over x. And then just like we did earlier today, we're going to substitute using the unit circle. So the tangent of pi over 3 is what value? Root 3. Yeah. Okay, now we just talked about how we want that in the form y equals mx plus b. Okay, so a line has the form y equals mx plus b. So to get there, what would I have to do here? If I want the form y equals mx plus b, I have to get y by itself. So what am I going to do? Yeah, multiply both sides by x. So if I multiply both sides by x, I have root 3 times x equals y. You can leave it like that, or if you want to put the y on the left side, you can. Okay, these are the rectangular coordinates. Okay, so sometimes your slope might be a radical. That's okay. In the polar coordinate world, that is fine. Okay, now for part B, you have the r equals, it's the negative cosine of theta. So just like we did in 8.1, your first step, if you have this cosine here and an r here, we're going to multiply both sides by r. So we get r squared equals negative r times the cosine of theta. Okay, this is to find your rectangular coordinates. And once we do that, we are going to graph. Okay, this one is going to be easier to graph from your rectangular coordinates. If you also want to see what happens when you plug it in your graphing calculator, you can. Okay, so just like we did earlier today, for r squared, you're going to plug in x squared plus y squared. We know that r times the cosine is negative x. Okay, so you're going to get everything to one side, and you're going to complete the square. Okay, so why don't you do that, and then you can graph that. when we were first going over this, I said a great thing to do is to organize what together. So what should we be organizing when we move over the x? Yeah, all of your x's, okay? So you should have an x squared plus an x, and then you can do the blank. If the y squared does not have a y to go with it, that's okay. That just means you don't have to complete the square there. Okay, so then once you organize that, now you can see what your value of b is going to be. Okay, I am concerned that we're having some trouble with this, and we already went over it today. Okay, so you're going to take your b value. All right, Gabby, what's your b value for this? What's your b value for your x's? Okay, so if we divide that by 2, we're just going to write it as what? Okay, so 1/2, and then it's squared. So 1/2 squared is going to be 1/4. Okay, and then Jackson, will you tell me what your equation is going to be here? Good, and then this is going to be plus, just because this here is going to be plus. Okay, so you have the x plus 1/2 squared plus y squared equals 1/4. Hey, nice job there. These are going to be your rectangular coordinates. Remember, the rectangular coordinates are an equation, all right? Now, when we're describing the graph, you can describe it from this equation alone. So we know that this is going to be a circle. Okay, and then, Zarish, what's the center going to be of this circle? Okay, so use your circle equation. Yeah, but do we know where that comes from? Okay. Okay, so when you're picking out your h and your k, you're going to do the opposite. So -1/2, 0, like you said. Okay, and then the radius is not the 1/4. You have to do what to it? Square root it. Okay, so our radius is going to be 1/2. Okay, so what you can do is find this center of the circle, and then you can do a radius of 1/2 and connect those points. Okay, we're also going to verify that with our graph. So you have negative cosine of theta, and look, if you press this variable button, it will give you theta now that you're in that mode. Okay, if you graph it, looks really teeny tiny. If you want to see that closer up, you can go to zoom. Just go to zoom in, press enter. Okay, and you can see the 1 here. This would be -1. So sometimes I just like to mark where the center is. So if you have -1/2, remember that if you have a negative, 0 is the radian value. The negative is going to go back here. So if this is halfway, this is going to be halfway, this is going to be halfway, and then I usually just estimate what that value is to create my circle. Okay, tomorrow I am going to show you how you can use the table in order to graph on a polar plane. And we're going to look at some different types of polar equations. Okay, so today we just looked at some circles and some lines. And then the only homework that's due tomorrow is your 8 and 1.